Two agents just wrote the same database query 3 times, and neither of them noticed. If you've watched your multi-agent system burn through tokens redoing work that was already finished, you know exactly how maddening that is. The question isn't whether your agents duplicate effort, it's which framework actually stops them from doing it. Let's start with why this happens at all. When you spin up multiple agents, each one operates with its own view of the task, unless something forces them to share state. Agent A doesn't know Agent B already scraped that web page, summarized that document, or called that API. The result is redundant tool calls, contradictory outputs, and a cost bill that balloons for no reason. Deduplication is the mechanism that says, this work is done, don't touch it again. In LangChain, deduplication isn't a switch you flip, it's something you architect. The framework gives you the primitives, a shared memory object, a state graph through LangGraph, and the ability to inspect what's already in that state before an agent acts. In practice, that means you build a checkpointer that records completed tasks, and each node checks the graph state before executing. I tested this with a research pipeline where 4 agents pulled from overlapping sources. Without a dedup guard, they fetched the same 3 URLs 11 times combined. After adding a simple scene set inside the shared state, that dropped to exactly 3 fetches. The power is total control. The cost is that you write and maintain that logic yourself. CrewAI takes a more opinionated approach. Tasks are first-class objects with defined outputs, and the framework's process model, sequential or hierarchical, is designed to pass completed context forward automatically. When Agent 1 finishes a task, its output becomes available to downstream agents without you wiring up memory by hand. In my same research scenario, CrewAI's hierarchical process with a manager agent naturally routed subtasks so the same source wasn't assigned twice. The manager acts like a dispatcher that remembers what it already delegated. But here's where the test got interesting. CrewAI's automatic context passing works beautifully when tasks are cleanly separated, but it stumbles when 2 agents independently decide they need the same tool mid-execution. Because the deduplication is task level, not tool call level, I still caught 2 agents hitting the same web search within a single delegated task. LangChain, precisely because you build the guard yourself, let me deduplicate at the exact granularity I needed, right down to individual tool invocations. So the numbers. On a 10-task workload, raw LangChain without guards produced roughly 40% redundant calls. CrewAI out of the box cut that to about 15% with 0 extra code, which is genuinely impressive for setup speed. But fully instrumented LangChain with a tool call cache and a state checkpointer got me down to under 3% redundancy. The trade-off is clear. CrewAI wins on effort to result, LangChain wins on ceiling. My honest recommendation depends on your stage. If you're prototyping or you want sensible defaults without babysitting state, CrewAI structure saves you real time and prevents the worst duplication automatically. If you're running this in production at scale, where every redundant API call is money and latency, LangChain's granular control pays for the extra engineering many times over. Neither is wrong. They optimize for different priorities. If this saved you a debugging headache, know that tomorrow I'm publishing the exact tool call caching layer I used to get LangChain under 3%. With the full code you can drop into your own project. Subscribe right now so that build lands in your feed the moment it goes live.